Okay, so this was our problem. We have 2 points A and B, certain kilometers apart, and there are again two stations or points in between point A and point B by name C and D. Okay, now we are looking from A to B, and the question here is that are the points A and B intervisible? Can we see point B from point A? Okay, so all the data are given. The elevation of point A, point B are given. Then point C, point D are given. Everything that is required is given. Let's just see the concept. So according to the question, it is like this. We will assume something like this. This is the surface of the earth. I'm drawing it just like this, just for our understanding. This is A point. This is the elevation at A point here. This is our datum actually. So the A point is somewhere here. And somewhere in between we have C point. This is the location of C and D point, not actually the height. Okay, C and D point are somewhere here. We don't know yet, we are not sure yet. And we have a B point here. Now we are asked from A, can we see B point or not? So first we need to do what we need to do. We need to find out what is the distance of the visible horizon. So first, this is our first line of sight, which goes like this. It touches the horizon like this and it goes this way, something like this. We will call this E point, and this is our horizon. Now we have that formula that we used yesterday, and from that formula we can find, because we know the elevation at point A, we know h, we can find out what is the d, what is the distance to the visible horizon, right? Now we are given all these data from A point to C point, what is the distance? From A point to D point, what is the distance? All these are given. Now, if we know those values, what we need to do, we need to find these heights. What is the height of the line of sight at C point, and what is the height of the line of sight at D point when we are looking at the horizon? Okay. So how we can find this? Because this will be again h. We are looking at the horizon here. If we know the distance C and E, then we can find out this h at C point, right? Now we already know what is the distance of A to C that is given in our question. This is given. We can find out distance from A to the E point, that is the horizon, from the formula. And then AE minus AC will give us the distance of CE, right? Now this can be a new D in the formula, and we can find H at C point. So that is the idea. Similarly, we can find ED, and we can find what is the height here at D point, right? And similarly, we can also find what is the height at this point, this height. Then in the next step, we will be trying to look from A point to B point directly. This is the ground point at A, and we will try to look at the ground point of B here. Done. Now the line of sight is passing through this point here, okay, and this point here. We will give them certain names. Say this earlier point is C1. Now this is C2. This earlier point was, say, small d1. Now this is small d2, like this. Now, we need to find out, is the point B visible from point A or not? When they will be visible, when the ground at C is below this line of sight, or the ground at D is also below this line of sight. Or again, saying the same thing, that if the line of sight is above the ground, if it is not obstructed by ground or some objects, then we can see from A point to B point. To know that, what do we have to do? We have to find out the elevation of the line of sight here, also the elevation of line of sight at D point. Then only we can find out, because the elevation of ground points are given, right? We have to find out where the ground is here at C point. Is it above this line of sight? It is somewhere here or somewhere here. If it is above, we cannot see, it is obstructed. It is below, it will pass, the line of sight will pass, and we will be able to see. So that is the idea. Now this we can do from the principle of similar triangle. Remember similar triangle? If we have similar triangle like this, two similar triangles, their angles are same, then their sides become proportional to each one, right? So if this is AC, ABC, and this is D and E, like this, then what happens? What happens if they are similar triangle? AC by AE is equal to AB by AD is equal to BC by DE, right? The similar sides are proportional. This side is proportional to this side, like this. So using that formula, we can find out what are these C1, C2, D1, D2, right? And then we will be able to find out what is the elevation. And we already know this one, right? We already know the elevation of B point. That means we know this distance from the reference point or reference line or datum. What is the elevation at B point? This value we know. This we found from the first calculation. So we can find out this, right? So we know this, and we know the distance from A to B. Then we can use the concept of similar triangle, because we also know the distance from A to D. So what we can say for example, at C point, we consider this triangle A, C2 and C1, and then we consider A, B, we will give it a name, small b1, a capital B, small b1, like this. Okay, so okay, and then from that similar triangle concept, we can find out what is the C1, C2, and D1, D2. We will add the initial value here, CC1 and DD1. We will add those values, and then we will find out what is this height. What is this height? Now, these are what? These are the elevation or RL of the line of sight at D point. Then we will compare that value with the ground value. Okay, say for example, this value is now 100 meter, and the ground at this point, say for example, is 80 meters. So then therefore the ground will be below, the line of sight is easily passing over the ground, right? So we will be able to see from A point to B point. If the ground RL is 120 meter, so the ground is above the line of sight, therefore the line of sight is obstructed by the ground, and we cannot see B point from A point. So that is our idea. Now, if it is not visible, then what we have to do? We have to put some signal over here, right? So we will find out what is the difference. And then say, for example, we add 2 meters or 3 meters, something like that for clearance purpose. And then we will join this, and we will come here. And then we will find out from the same principles of similar triangle, what is the height required here. So what is the height of signal required at point B? We will find out. Okay, so it becomes like this, right? It becomes like this. Here we have A point, here we have C1 point, here we have C2 point, here we have D1 point, here we have D2 point, here we have D1 point, here we have ground B point. It is like this. So from here, what we can write, if we take this triangle and the bigger triangle, we can write A C1 divided by A B1. This is equal to what we can write, again similar sides, this side and this side, C1 C2 B1 B, right? So writing this type of similar triangle conditions, we can find out these values C1 C2 that we require. Now let's go back here and see. So what we are doing, so this is our condition. First, we are looking from A point to the horizon, and we are trying to find out the C1, D1. Okay. So we have this formula, the same formula that we use for the other problem. At H is what? Elevation above the datum. At A point, it is 220 meter. So the distance to the horizon becomes 57.09 kilometer. Now we know all the other distances, A to C, A to D, these are given. So AE, from A point to the horizon, it is 57.09 kilometer. These are given, A to C, A to D, A to B are given. So what we can do, the in-between, what we can do, the in-between points we can find out. So here we are assuming okay, fine. So C to E, what will be C to E? This AE minus AC, right? So it was like this, remember? It was like this. First, what we did, we found the distance to the visible horizon. This is E point, this is A point, and this is where we have C point, right? So we know this distance and we know this distance from the formula. So this minus this, we get this value. And yeah, okay. And we're just assuming that they are the same distance, right? From here, this distance and this distance are same. We are assuming because this is a, like this, right? So we are assuming they are same distance because it is a huge triangle with a very small angle here, right? This is how much? This is 57 kilometer, and this is how much? 220 meter only, right? Therefore, we are assuming that this is almost equal. If this is 57 kilometer, if this is 57 kilometer, we are assuming this is almost 57 kilometer as well, like that. So then after subtracting, we are finding out all the distances from the horizon. Okay, 57.09 minus 50, we got this distance from horizon of C point. Similarly, we got the distance of the horizon from the D point and B point, right? Now, again, we will use our formula because these are distances from the horizon, the D in the formula. Using D, we can find out H in the equation. So we are finding out height at all the points. We are finding out this height now, this height. Initially, we know D height, we found D. Now, after knowing this D, we are finding out these D's at different points. And from this second round of D's, we are finding out this H at this point by the same formula. Okay. So, same formula, the CC1 is H and CE is the D. CC1 will be in meter and this D will be in kilometer, right? So we are finding out CC1 DD1 and BB1, the elevations when we are looking at the horizon of all the points we found. Now the second step, what we will do, we will from A point, we will try to look at B point. A point at from the ground level of A point, we will try to look at ground level of B point. Okay, and then see if it is going over the ground point or not. So here what we do. So now in the second step, we are at A point, we are trying to look at the ground point at B. Okay, now we have another height. The line of sight is now increased. Initially the line of sight was looking at the horizon. Now the line of sight is looking at the ground point at B. So there is some height increment at C point and D point. We have to find them. We will find that using this similar triangle concept. A, C1, C2, D1, D2. Okay, from this triangle, what we can write, the same sides are proportional. We can write C1, C2 divided by C1, C2 divided by BB1. Okay, this triangle is here. Sorry. Okay, I didn't draw the BB1, but same concept only. Okay, same concept only. The similar sides will be proportional. From there, we want to find out this C1, C2. BB1 we already found from the formula, this value, and AC1 we will assume it is almost equal to AC, the ground point distances, and AB1 we will assume it is almost equal to the ground point distance, capital AB, right? So doing that, we can find out what is C1, C2, what is D1, D2. It was like this. First, we were here at A point. We looked at the horizon at the first step, right? Like this. When we looked at the horizon and we found this distance, from there, we found the corresponding other distances here. We found these H here. We found these H here. This is our C. This is our D. And here we have B. Now what we are trying to do, this is the ground point of B, somewhere here. This is the datum or reference line, but the ground point is somewhere here. The ground point is here. Now from the ground point of A, we are trying to look at the ground point of B, right? So what happened? C1, C2, there is this increment in height of line of sight. D1, D2. Now we need these values, and for that we are using the similar triangle concept. Okay. Yeah. And what we did, from the formula, we got this value. From the formula, we got these values, right? These H's, we got these values from the formula. Now at B point, we know the elevation. That means we know the distance from the vertical distance from the datum we know. So from this value, we subtracted this much and we got this value, right? Now we are using this B1, capital B. What is that? This value. This is the elevation here, B1, from B to B1. This value, this is h, this is the small h here. So the elevation, total elevation is 1160 meter. From total elevation, we are subtracting the h that we got from the formula, so that we are getting the other value. Okay, here, what is the actual elevation from this line of sight when we are trying to look at the horizon? Okay, so that is the idea. After that, we are using the concept of similar triangle, and we are finding out this this C1, C2, and D1, D2. Now, what we will do, we already know this from the initial formula. So this plus this, we will get the elevation of line of sight at C point. And again, the earlier value from the formula plus the new value from the similar triangle category, we will get the elevation at D point, right? So that is what we are doing here. Okay, we are adding them, and we saw that elevation of ground is 308 meter. This is given in the question. RL of C point is 308 meter, and the RL of the line of sight is 311 meter. All right. At C point, it is like this. C point, 308 meter. The RL here from the datum. This is datum. So this is 308 meter. And the line of sight is passing through like this, right? So this is 311 meters. So the line of sight is clear of the ground. So there is no obstruction. And then the same addition at D point, we found 627 meter, but the elevation is 632 meter. But at D point, what happened? The ground is 632 meter, but the line of sight here is below this 627 meter. So therefore, the line of sight is obstructed by the ground, and we cannot see the B point because the line of sight got obstructed at D point. It was clear at C point, but it is obstructed at D point. Right? So therefore, what we have to do, we have to put a signal at B point so that we can see. First, we calculate the line of sight fails to clear D by how much? The ground is at elevation of 632. Line of sight is 627.8 meter. So 4.2 meter below the ground, right? So we have to raise it. We are assuming that we will raise the line of sight by a height 3 meter clearance from the ground. It can be an assumed value if it is not given in the question. 2 meter, 2.5 meter, 3 meter, something like that, we can assume. So the line of sight has to be raised at D point by how much? 3 meter we are considering clearance, and 4.2 meter because it is below 4.2 meter from the actual ground at D point. So 7.2 meter. Now again, we use the same similar triangle concept. Now it is like this. It was like this. From A point, we looked at the ground of B point, right? We have C point here, we have D point here. So the D point is above, the C point is below. So we have to raise it by how much? We calculated that it is 7.2 meter here, right? And we will require some signal over there. Now we will join this. This height now we know this is should be 4.2 meter because it is below 4.2 meter at the ground, and 3 meter we are considering extra. So 7.2 meter it is here and it goes here, right? Now this is your A point, this is your D, this is your B. Same similar triangle concept. Now you know this value. This is AD, this is AB is also known given in the question. And now we need to find out what is this B, and say, for example, B star, which is going to be height of the signal. Okay. So that we require, and for that also we will use the same similar triangle concept. Okay, so the height required is this much value.